Okay, so if you mean, we have a function here. So y equals f at x. And we start from A and we finish at B. So we would like to find the area from A to B. Here's how you write it with the integral symbol. Area is equal to the integration from A to B for the function. Okay, this is provided that f at x is greater than 0. Okay, it's above the x-axis. Now, let's write the equivalent sigma notation symbol for this. Okay, so sigma notation always involves limits. Okay, what is delta x in this case, in this general case? Delta x will be the following: the interval, which we can represent with b minus a divided by n. Okay, so here's the general formula: xi times by delta x, right? We found delta x. So let's use the right hand sum because it's easiest to write. Okay, for the xi. Xi will be a plus, and then you have to just add the delta x. Okay, delta x times by I. This is the right hand sum. Very easy. So a plus b minus a over n times by I. Okay, do you understand this? This is actually what we've been doing all along for the right hand sum. So it's the function a plus b minus a over n I times by delta x, which is another b minus a over n. You can see why we use this symbol, right? Yeah. You know, in the beginning, mathematicians were like, okay, this is what we mean, right? They use this for maybe, 30, 40 years, whatever, and they're like, okay, I'm sick of using this. Let's use this. Okay, so they actually mean the same thing, these two. Okay, so let's analyze a little bit further. How can we identify this is this? First of all, this A matches this A, right? The starting point. Yep. Okay. How do you find B? Okay, we find B from here at the back. The delta x, you set, your starting number to be A, and then B will come out. Okay, so this still sounds confusing without actual discrete numbers. So let's go into an example.